Hello everyone, this is a video tutorial on a solution of a problem related to energy principle and work. So here is the question. A metal block of mass 3 kg is moving downwards with speed 2 meter per second, where the bottom of the block is 0.8 meter above the floor. When the bottom of the block is 0.4 meter above the floor, it strikes the top of a relaxed spring 0.4 meter in height. The stiffness of the spring is 2000 Newton per meter. So the first part of the question asks us, the block continues downward, compressing the spring. When the bottom of the block is 0.3 meter above the floor, what is its speed? Here we need to consider that both earth and spring are part of the system. So there are two potential energy terms, one for the block and spring and one for the block and earth. Since the mass of the spring is negligible, there is not a spring plus earth potential energy term. And let's see the solution. Here the system is the earth plus block plus spring, and there's initial state, the block is 0.8 meter above the floor and the initial speed is 2 meter per second. Final state is block is 0.3 meter above the floor and spring is compressed. So according to energy principle, energy final is equal to energy initial plus work done. Since we are calculating the work done by the spring and initially there is no load on the spring, so work done is 0. And as we expand for the energy final, we have kinetic energy final, we have kinetic energy, we have a potential energy of the spring, we have gravitational potential. And on the initial side we have initial kinetic energy because we have initial velocity, and our initial spring potential is 0 since there is no load, and there is the initial gravitational potential, and as I said, the work is already 0. So as we expand with our formulas, there is one thing we need to consider. For the height that we take while we calculate the spring potential is the height that is measured when the spring is compressed and when it is relaxed. So the height that is S that we are calculating is given by 0.4, that is the relaxed length, minus 0.3, that is the compressed length, and that gives us 0.1. As for the gravitational potential, we have to calculate the change in height of the block from its initial state to its final state. So doing that, we get 0.8 minus 0.3 and the value is 0.5. As we plug in those values, we should get a final velocity of 2.7 meter per second. So let's go towards the second part. I'm sorry that I don't have my second question written here, but my second question asks that the block eventually hits back upward, loses contact with the spring and continues upward. So what we need to find out is what is the maximum height reached by the bottom of the block above the floor. So we have to consider one thing, that we are calculating this after the block has lost contact with the spring. Hence the spring is already relaxed, and in final state the block is at the highest point where the final velocity is 0 and the spring is relaxed. So according to energy principle, energy final is equal to energy plus work done. Since the spring is relaxed, the work is still 0. On the final side, we have a final kinetic energy 0 because our final velocity is 0, and our final spring potential is 0 because the spring has no load on it at that point, and there is the final gravitational potential. And on our initial side, there is initial kinetic energy because we have an initial velocity, and the initial spring potential is 0 because there is no load on it, the work is 0, and the initial gravitational potential is there. So as we plug in the formulas and the values, we should get a maximum height of 1 meter. Thank you.